Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for tonight. We are going to be graphing exponential functions. But before we do so, let's remember how to graph a linear function, something that looks like this. All right, well, the first thing I would do would be to find the y-intercept, which would be 0 in this case. And my slope would be 2 over 1, so I'd rise 2, run 1, rise 2, run 1, rise 2, run 1. That looks pretty good, and then I would draw my line, right? Now, let me see here. I'm going to get a nice, pretty accurate line, pardon me there. All right, so there we are. Now, remember, if we look at a t-table like this, it's probably pretty easy to predict. I mean, 0, we get 0. When x is 1, we get 2. When x is 2, we get 4. X is 3, we get, oh, and not 8, silly Mr. Lawrence, we get 6. Okay, and you can see that the x values are being multiplied by 2, right? They're doubling every time. And you get a nice linear relationship. But what happens when you have an equation, say, like this, y equals 2 to the power x? Okay, that is not going to be linear. And before we try to graph it, let's make a t-table and see what's going to happen with it. All right, x and y, and I'm not going to start at 0, but I'll show 0 first, and I'll do 1, 2, 3, and then I'll explore and see what happens. All right. Well, when I do 2 to the 0 power, any non-zero number to the 0 power is 1, right? So 0, 1 is going to be a point on this graph. All right, when x is 1, then y is 2. So 1, 2. Oh my goodness, Mr. Lawrence, what are you graphing here? 0, 1 is going to be on the graph. There we go. All right, when x is 1, y is 2. Oh, look, the two graphs cross right there. When x is 2, y is 4. 1, 2, 3, 4. Ooh, they cross again. That won't happen anymore, though. And when x is 3, y is 8. Okay, so 3, 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, in case you're wondering, I mean, 4 would be 16, and x is 5, you'd get 32 and 64. That the y value is going to continually double, whereas this y value is going up by 2 every time, plus 2. This one's going times 2. And you should remember from back when we did patterns way back in the first quarter that when we have it doubling every time, there's going to be some kind of exponent going on. All right, now this part of the graph here is going to go like that, and that puppy is going to climb, and it's going to climb very fast, and it's going to shoot way up. It's going to shoot up so fast that it might even look like it's going to go vertical. It never will. It never will go vertical, but it'll be climbing so steep that it will look like it's vertical. Okay, now let's see what happens when x is negative. Well, when 2 to the negative first, you should be experts at that by now to know that that's 1/2. So I'm at -1, I'm at 1/2. When x is -2, well, 2 to the second is 4. 2 to the negative second would be 1/4. Okay. And you see it's just going to keep getting closer and closer and closer to the y-axis. It will never touch the y-axis. It is not possible to get y to be 0 in this equation. It's not possible. In fact, this x-axis is like a barrier. It's like a magical barrier. We call it an asymptote. Asymptote. All right? And there's this magical barrier here. The graph will get closer and closer and closer to it. If you could zoom in and zoom in and zoom in and zoom in, as x gets smaller and smaller and smaller, like, -1,000, -2,000, the y values will get tinier and tinier and tinier. They'll become like 0.000000001, and then 0.65 zeros, and then a 1. It'll get smaller and smaller and smaller, but they will never be 0 on the nose. Okay, this is an exponential graph, and all exponential graphs will have this kind of half-pipe look to them. Okay, they might not all go the same direction, they might not all have the same asymptote, but they'll all go the same place. All right, so by the way, the asymptote of this equation, the asymptote would be the equation y equals 0, because it's the x-axis, right? Yeah, okay. All right, let's try another one here. Let me clone my graph and bring it on down. There we go. And let's say this time we have the equation y equal to negative 3 to the power x. Okay. Again, I can make a t-table. And let's put negative 2, negative 1, 0, 1, 2, and we'll put 3 in also. Okay. Well, when I put 0 in for x, 3 to 0 becomes 1, becomes negative 1. So 0 is at negative 1, right? If I put 1 in, I'm going to get 3. It's going to be negative 3. 1, 2, 3. When I put 2 in, I'm going to get negative 8. 3. Oh, no, I am not, Mr. Lawrence. I'm going to get negative 9. Excuse me. All right, 1, 2, negative 9. Now, negative 3 is not going to show up on my graph. I'm not going to actually plot it, but, excuse me. I know 3 to the third is 27, so this will be negative 27. All right, negative 1 is going to give me a 1/3, but then it's going to be a negative 1/3. And then I'm going to get a negative 1/9 here. All right, so I'm going to get a 1/3, and then a negative 1/9, and then they're going to get closer and closer and closer to the y-axis. They will never actually hit it, never. So the graph is going to do something like this. Okay. Now, you might see here, it looks like I'm hitting the y-axis. Or the x-axis, excuse me. That is my human error. Okay, it will actually never touch. So if I wanted to get a little bit more accurate picture, I guess I could kind of go like that, so you can see just a teeny little bit of space there. Okay, but it will never touch the x-axis. Again, in this problem, the asymptote, the invisible barrier that the line will never cross, that the curve will never cross, would be the line y equals 0. Right? Now, some of you are thinking, oh, it's always going to be y equals 0. No, of course it's not. Of course it's not. You have to, there are no shortcuts in math. You have to stop and think about what's happening. Let's see one where the asymptote is not the x-axis. Okay, let's try this one. Let's go with the equation y equals 2 to the power x plus 3. Okay. And we'll go negative 2, negative 1, 0, 1, 2. Okay, now 2 to the second is 4, plus 3 is 7. 1 to the second plus 3 is 5. 2 to the 0 power plus 3 is 4. 2 to the negative first is 1/2. So this will be 3 1/2. To the negative second would be 1/4. So this will be 3 1/4. All right, some of you can tell where the asymptote is going to be. Let's see, 2, 7, 10, 9, 8, 7. 2 7's right there. 1, 5, 1, 2, 3, 4, 5. 0, 4 would be right there. Negative 1, 1, 2, 3 1/2. Negative 2, 3 1/4. All right, now if you're still not sure, I'll tell you what, plug negative 3 in, and we're going to get 1/8, so this will be 3 1/8. You can see as x gets smaller and smaller in the negative direction that these points are getting closer and closer to this line right here. Right? That would be the line y equals 3, because y is always 3 on that line. So if I go to draw this curve, it's going to look something like this. And there we go. And again, it will never go vertical. It'll climb really, really steep where I'm only moving over 1 in the x direction, but then moving a whole long way in the y direction. And then it'll also appear to go horizontal, but it actually isn't. It's getting closer and closer and closer to its asymptote. Okay? All right, I think that's it for the lesson today. Tomorrow in class, you'll be practicing on graphing these. And then, let me see what's today. Today's Tuesday, so tomorrow will be Wednesday. The next day is Thursday. Thursday, we're going to talk about something really cool that has to do with this exponential growth, something in the real world that some people say is a hoax and some people say is a miracle. Anyway, we will talk about it and we'll look at some images and we'll talk about how exponential growth and radioactive decay fit into the real world. All right, Mr. Lawrence signing off. Good night, everybody.